All right, welcome back to another week of Kernel Dev Gardening, week 24. We're working on Userspace again. So we started it last time, and we're going to continue with it this time. And in particular, I am following this lab from MIT, this MIT class. Post the link in the chat. As usual, I'll test if my chat widget is working with the test 1. And yeah, I'm pretty excited. These functions that we're going to work on today seem pretty interesting. And yeah, I hope it'll be good. Just quickly checking that everything is good with the audio, and it seems okay to me. So I guess, yeah, let's just get going. I need to clean up my working tree a little bit because I have all this stuff from last time. So what did we do? I implemented this unit test, and we're calling it here. And something about making this not static. Why would we want to do that? I don't immediately remember why we were doing that. We were exposing bootmap region for some reason. Was it because we were planning to use it for the tests maybe, or I don't totally know. I'm just gonna ignore that. Okay. Check region alloc, and yo, hey digitalized, hope you're doing well. Okay, let's just get into it. Make sure, so we'll just make sure the kernel still runs like from last time, and region alloc tests passed. And so let me just kind of get oriented again. So in general, it's not pmap. Where so mem init, and where is this called from again? It's just regular init.c. Hey Kefler, hope you're doing well too. Nice to see you. Thanks for joining. Hey Publish, what's up? What are you guys up to today? What are y'all up to today? Yo, Coreyvot, what's going on? Everyone's in the chat right now. This is sick. Weird. Everyone's very on time today. Oh man, you got your account suspended. I'm sorry to hear that. Okay, so I was right here. Hey Barry, welcome back. RTOS project. Nice. Do you mean you're working on an RTOS project, Plebish? So, all right, so I was working on I was working on env init, or I was working on all this stuff last time. Just to recap, so here we are, lab 3, and I made it through the first 3 functions last time, and hopefully, if I'm lucky, maybe I'll get to finish the last 3 functions today. And last time I did env init, env setup VM, and region alloc, which were these functions, these like helper functions I needed to implement. And then we ended by writing some unit tests for the I guess env setup VM in particular. That was this was the function where I copied and pasted a bunch of stuff. Helping friend with their library for OS deving, nice. OS dev library. Rereading some old algo notes for interview prep. Oh man, coding interviews. It's been a while since I've done one, and I'm not looking forward to the next time I have to do one, which I'm not sure when that will be. Hopefully not too soon. Yeah, although I have to say, I think streaming has actually made me better prepared for coding interviews because it forces me to kind of just talk a lot when I code, which I think is actually an important skill when you're doing coding interviews, is just to talk and say what you think, which I will do right now. So yeah, so we had this function, and it was doing some virtual memory stuff. It was kind of copy and pasted from this other place. Okay. And I'm just gonna, let's just do it. Load iCode. You'll need to parse an ELF image, much like the bootloader does, and load its contents into the user address space of a new environment. Cool. Okay, let's find that. Load iCode. All right, these are huge comments. Wow, these are massive comments. Okay, but let me get my context back a little bit. So we're in the main, we're still like kind of like initializing the kernel. We initialized virtual memory and stuff, which was over here, and basically set up a production memory layout and then switched to it. Next, we set up the basic infrastructure for managing all the user environments, as it's calling them, which are basically just processes. And then now, I guess now I'm not sure who's going to call load iCode, but it's just saying we need to implement it. So, or maybe, I guess it's going to be one of these later ones. So, yeah. All right, back to load iCode. Let's read the comment. Set up the initial program binary stack and processor flags for a user process, only called during kernel initialization before running the first user mode environment. This function loads all loadable segments from the ELF binary image into the environment's user memory, starting at the appropriate virtual address indicated in the ELF header. At the same time, it clears to 0 any portions of these segments that are marked as mapped, but not actually present, so like the BSS. One second. I hope the music's not too loud. I always never really know how it appears in the stream, or like how the volume mixes. But yeah. All right, back to this. All this is very similar to the bootloader, except the bootloader also needs to read the code from disk. So we don't need to do this because I believe we're kind of using some hack where all of these user programs are actually like compiled into the kernel using something with the linker. So that should be a little bit simpler, hopefully. Finally, this function maps one page for the program's initial stack. Panic if it encounters problems. How might it fail? What might be wrong with the given input? I'm just going to do some brainstorming right now. The ELF binary is malformed. Yeah, the ELF binary, like, which could mean so many different things. The header is corrupted. The program headers look strange. I don't know, something like this. Okay. So there's two parts here. Hints, load each program segment into virtual memory. Add the address specified in the elf section. You should only load segments with type that are loadable. The virtual address is found in the virtual address field and the size of memory and the mem size. The file size bytes from the elf binary starting from should be copied to virtual address PA. This is nice. This is really helpful. I've never actually implemented an elf loader before. I have like worked with them and like worked around them, but I've never written one. So I don't know exactly all these like random fields and stuff. So yeah, hopefully I should be able to do it though. And your remaining memory byte should be cleared to 0. The elf header should have a file size as less than or equal to the mem size. Use functions from the previous lab to allocate and map pages. What were those again? I guess that would be lab 2. Which was like page, yeah, all these page insert, page remove, stuff like that, I think. So we can't use boot map region because that's only for the boot process and only for like kernel, the kernel pages, I believe. Okay, all page protection bits should be user read/write for now. Interesting. Elf segments are not necessarily page aligned. But you can assume for this function that no two segments will touch the same virtual page. Hey, Nikhil. Yeah, I am a software engineer. Yep. But I don't work on operating systems at my job. Those two segments will touch the same virtual page. Okay, so no overlapping segments. You may find a function like region alloc useful. What? Yeah, and like, even though I wrote it last time, what is it? How do you use it again? It basically can, it just maps a bunch of space inside the environment, which sounds useful, starting at some virtual address in the environment, but doesn't touch it in any way. And they're writable by Userspace and kernel. Okay. So I would maybe hope that I don't even need to be manually calling page insert and page alloc then. If this helper function that I did last time already helps me. Okay. Loading the segments is much simpler if you can move data directly into the virtual address stored in the elf binary. So which page directory should be enforced during this function? Ooh. Okay. Okay. mean, I think the answer is that the page directory of the environment, but I am kind of blanking on the more basic context of like what page directory is even active right now. I guess the kernel, the kernel's page directory is probably active. I mean, right? That's probably the case because the last thing we do, well, as we load current pager, so we're operating on this current pager thing. But but maybe we need to switch to the processes page directory. You must also do something with the program's entry point. Wait, what? You must also do something with the program's entry point to make sure the environment starts executing there. What? What is that? What? Cnv run and pop tf below your code here. Now map one page for the program's initial stack. That virtual address uStack top minus page size. Okay. Okay, interesting. To be honest, I am a little bit overwhelmed. It's like a lot of stuff. It's not a lot of hand-holding, and I understand, I think, the general ideas, but not totally everything. Just checking the chat really quickly. Nikhil, you do web stuff in your job? No, I don't do web development, but I don't also do operating systems development. I work on a hardware product at my job, and I write software for it, but it's not that low level. And hey, Joshua. Streaming setup, I'm using an extremely normal streaming setup. I'm using OBS, and yeah, I'm using a very normal streaming setup. I have Streamlabs set up for the chat widget and stuff. It's pretty much it. Nothing too special. Visualized loading elf headers for class. I did not do well. Yeah. All right, let's just let me try to start this. Okay, so we need to load in. So we get a binary passed in, but also like what? We get a pointer. We get a buffer passed in, and what is like quite strange to me is that we don't have a size on the buffer. Okay, 20-second break, stand up and stretch, get some water. It's pretty odd to me that there's no size argument that's also passed in. Almost like usually when you're dealing with buffers, there's like you pass the buffer, a pointer, and a size. Okay, it also looks like this function's never called yet, so I have no idea what the call site would look like. Okay, man, well, okay. There's like a bunch of things I need to do apparently, so I'm just going to try to write them down. So the first thing is just load the elf binary into the process, into the address space. And so, okay, so if presumably this thing is pointing at an elf binary, And we have this environment structure. So I'm just going to quickly add some asserts that both of them are valid. Yeah, why not? I believe. Yo, Lizard. Good to see you, man. Okay. So the question, so basically, I understand that conceptually, okay, we have this elf binary, and it's also, we can also like sort of half cheat and read the bootloader, which needs to do a very similar thing, as it says, boot main to C. It's going to be basically a very similar thing to this. And it's not that much code. It's not that much code. The question is, what do we... Yeah. I can locate the elf segments, and then where do I write them, though? Also, how do I test this, that this works? I have no idea how I'm going to test that this works without just blazing through the rest of these functions, but whatever. Okay, I understand this stuff. Like, I understand the basic mechanics of loading the elf header, but it's just like where, it's more of loading it into the address space, right? So I'm trying to load it. So I understand this. I understand this paragraph too. That generally makes sense to me. All protection bits should be read-write. Are not necessarily page aligned, but you can region alloc. Loading the segments is much simpler if you can move data directly into the virtual address stored in the binary. I mean, I'm just gonna take that to mean that we should switch the page directory to the environment one. I'm very much just guessing here, but I'm just gonna try to move on. So first thing I'm going to do is copy and paste the code. For changing, doing this. And so, oops, page dir. Switch to env page dir. And then, I don't know, at the end, I guess, I need to switch back. And I'm going to put some, I don't really know if that's correct. I kind of hope it is. Actually, just out of curiosity, I can even add a assert false. Or what am I doing? Or just panic. And of load because I don't really know the consequences of changing the CR3 like that. So I'm not even totally sure that's valid. And I kind of want to go back here and maybe I'll just add a unit test. Check load icode. Check region alloc. So I'll make a new one. load I code. And there's probably some headers I need to update. And yeah. But hopefully does this run? It says region out tests passed. So no, it's not. Okay, I see. So it's panicking in my tests here now, so I can safely get rid of this panic. Check load icode. So now, okay, so now I'm in the checker function. Hey, yeah, I have just the thing for you, Nikhil. I have my handy Learn Systems Programming Resources Guide. Check that out, and also feel free to join the Discord. A lot of other people are interested in that too. So now we're here, and now I can do all of the same stuff I did below to basically set up a fake little environment to start doing some tests with. And then yeah, so just quick test, does this work? Check load I code 3621. So that's all working. So now we can call load I code, but the unfortunate thing is that load I code is like is static, which or maybe that's fine. I kind of Can't recommend enough. Okay, nice. I actually haven't read that book. Okay, but basically, yeah, so check load I code. And load I code is a bit lower, so this is not going to compile, so we need to move this down. Below. Okay, so now our function is below, and this might even work. This is going to crash or whatever because I'm passing in a null pointer, but I wonder if this, yeah, assertion failed binary. So good. So now we have our little test harness for actually trying to run some of this stuff. And my next question is basically, where can I get the elf so like output or no object kern symbols, right? And there's all these like programs that apparently have been linked into the kernel. Doesn't matter which one. I just want the smallest one possible. Hello. So we have all these programs here, apparently. Hello does some stuff. Is there an even smaller one? Okay. Breakpoint trap. That looks nice and small. Buggy hello. Div by 0. Evil hello. Default read, I think default write, that could be maybe a good one, although I'm not prepared to handle that. I have the suspicion that breakpoint is the simplest, smallest one. So, yeah. I got kind of confused. Where was I just now? Okay. Here we go. So now I want to pass binary. Wow. I guess I can't get a... Oh, this is all the size. Interesting. Breakpoint. Start. There we go. So these symbols, maybe, I kind of don't know what I'm doing here, but like, oh wait, I need to do something weird, like extern char, no, this, I think, right? I need to like do the extern char weird thing. And so now, presumably, that actually is a pointer to an actual elf. And now it's actually going to try to run some of this. So I'm going to put a panic here. Load, iCode working. Okay. But my compiler didn't like that. Check. Okay, because it's like interesting. I need to cast it. Something like that. Load iCode working. Good. Good. So now clean this up a little bit, clean up this pane. So now we have our kind of like test harness on the left, and we have our actual function that I'm trying to figure out how to write on the right. And my actual question that I wasn't sure was like, is it what does the kernel crash if I do these lines, or is it okay? That is something I just totally don't know. I just copied that from here. Just curious, who else is calling LCR3? And how do they do that? Okay, two of the ones are things that I just added. Env-free, which apparently was already written or something. Okay, calls in this way, so I think I'm doing it right. So that's a good sign. Okay, so let's give that a run. Where am I? Okay, this is a bit, I'm going to clean up some of these tabs. It's getting a bit messy. Okay. End of load iCode. I hoped we see that. End of load iCode. Okay, that means it's legit. That means it's, at the very least, it's not, doesn't crash the kernel to call it load CR3 like that, which is good. And now I can, like, now I can code or something. So now let's pull up, well, now let's, this comment is so long. Okay. Now let's do it. So we have the binary, and I'm actually just going to jump to main.c because I kind of don't know what's off the top of my head. So we're going to first we should verify that it's a valid elf. And we can even do that in the unit tests. Although it says to panic if there's any errors, which kind of sucks because I can't unit test that. Why is it a void? Can I just not do that? I think I'm going to make it return an int so I can return errors and not just panic all the time. But okay. So we need to, so apparently what? The elf header is just some address there. Ah. But what, wait a sec. Oh, it's casted to a struct elf. So we have some, apparently we have some nifty elf headers or something like this, which is always super nifty and useful to have. So I'm just going to do struct elf equals binary, and if elf e magic is not equal to whatever, what's the magic supposed to be? Okay, elf magic return -1. And here's the part where I need to go and make this return an int. So now my why is that? Okay. Now my unit test code here. So now I can, okay, I'm just going to comment this out. So for the moment, I'm just going to pass some garbage in. Garbage. And I'm, oops, garbage. I'm gonna pass some garbage in. Assert that ret is equal to -1. Let's try that. Does that work? Initialization. Oh, from incompatible pointer type. Okay. What are the best? Hey, Ivan. What are the best resources to learn C? It's been a while since I learned C for the first time, but I liked the book called Learn C the Hard Way. I think that's what I used to at least kind of get going with learning C. Interesting that I need to cast it like this. Okay. Conflicting types. Oh man. Wait, did I change the wrong thing? I think oh yeah, I totally did. It's not, oh wait. No, yeah. Yeah, I changed the wrong header. Load icode doesn't have a prototype because it's a static function. So no need to change. Oh, what's going on? Shit. Okay, something bad happened. It started rebooting, I think. Okay, that was exciting. What happened? Okay, let's take this slow and steady. So here 1. So oops. Okay, even that is rebooting like crazy. Okay, that's exciting. Wait a second, what? Wait, okay, so I actually don't know. So, okay. Okay. Pre-garbage. Panic before that. Okay, that is okay. So the pre-garbage panic is fine, but then load iCode. Debugging panic. Okay, so do we hit this? Yes. Okay, now let's move this down. I could have sworn I tested this, right? Didn't I just test this? We can switch to the end page. Oh, but wait, yeah, I definitely thought I tested this. But that's okay, that's not even working. What? Wow. Interesting. Oh, wait. Okay, I think, okay, interesting. So I kind of tested something. Okay, this might be kind of bad actually. Okay, so what did I tested this thing. And previously I tested switching into the page directory and switching back out and then calling panic, and that worked. But what I didn't test is I didn't test trying to do anything inside of here. X equals 42? I don't know. Does this work? That works. But it does not work to panic, which is kind of bad. Like panicking, being able to panic is like one of the most important things that I do for debugging. So the fact that that doesn't work is kind of crazy. And frankly, I don't know how to debug that. Like, I have no idea what to do if the computer just starts rebooting all the time, which is what's happening. Okay, scary stuff, but we'll get back to it in 20 seconds. Okay, I don't know. To me, I have no idea. So what is interesting, yeah, so I can't panic. Like, the act of trying to panic with the page directory set causes like, yeah, like reboots. Probably because some virtual memory thing is messed up. But apparently I can just execute some code though. It's fine to just, I can run code, I think. Like, I can continue doing stuff and get back out of this, but for some reason I just can't panic. Which to me, that signals that I did, like, that my env setup VM function is wrong. Because I don't actually know how to debug this, but my guess is that something is wrong with the virtual memory, which is causing like double faults or triple faults or something like that. I don't have any interrupt handlers set up, so I can't handle any of the faults, and so that triggers like a triple fault and it reboots the machine. But I'm not quite sure how to fix that because I don't really know what the problem is. I'm just going to do another. So the original code was like, it was pretty simple, right? Or like, what about just return? Oh, interesting. Interesting. Okay, so I failed to reset to the kernel page directory before exiting the function. Maybe that's related to it. Maybe if I return to the kernel's page directory before returning, and that okay, 520 check load icode, and it passed. So I think that was the important thing. So I'm going to go and fail return -1. Go to exit, go to fail or I don't know. I'm just going to do this. Something like that. I don't know. And so the key, I don't really get what was happening, but I was switching into the environment's page directory and like resetting virtual memory to be basically what it says there. And I was exiting with an error code, but I forgot to clean that up on my way out of the function. And I was like, then it returned into the, kernel. And then maybe tried to access things it wasn't able to access. I don't really know. But, I don't know. But it seems like properly cleaning up on the way out fixes that crazy reboot thing that happened. And it also seems like my assert is working, because I could say assert red equals -2, and this is going to fail because it returns -1. So nice, I have like, so okay, cool. So my little unit test is working. Good. Still don't quite know why panicking. I mean, to really understand, like, it's important to actually understand what virtual memory setup when the environment is active, and that's determined by this thing completely. Where we do everything. We like completely set up the virtual memory here. We like allocate a page for the page directory itself. And then we like mutate in stuff into it to map things in there. And I kind of don't, like maybe I forgot something, I don't know. But I copied and pasted all the code I had for setting up the kernel's page directory. And I think the important part, I don't know, the kernel's code and stuff lives in this high region, but I'm pretty sure that's what I map in this last part. Okay, whatever. I'm just going to try to keep going. So we've tested the magic, and then what? Main.c, right? So now how does this work? White theme warlord. Love it. Love it. Hey, Afnan. Okay. Load each program segment. So in order to do that, you get you get a pointer to the program headers, which you can get with the program header offset. I wonder if manelf, no, of course manelf does not work on Mac OS, but it works here. So yeah, the program, so we have like all this stuff in the elf header. Crucially, we have like the program header offset and the number of program headers, and also the end size. Music just started. Has it been going? What is that? Holds the size in bytes of one entry in the program header table. Is that used here? I don't see it. Okay. So I need to pull up my elf. I'll try to do this without looking as much as possible. Okay, program header equals oops, whoa. Okay. So I was just trying some strategy of looping over all the program header base. Let me just program headers. No, it's just a sec. There it is. Yeah. Yep. I'm just gonna reference this real quick though. I did the same thing, right? Basically, the starting point plus the offset gets the program headers, and then they do something kind of interesting where they compute like an end pointer, but I'm doing basically the same thing. It would be cool if I could dump them somehow, but I mean, maybe I'll just try to do that. Maybe I'll add some debug prints as I go. I can't panic within this. Somehow I can't, like, I wonder if I can do cprintf actually. Was that going to, that's gonna make it kind of hard. Oh man, it's so annoying. Like, what's the error? Oh. It's pretty annoying. So apparently I was actually able to call cprint. Wait, no, did that work? No. Wait a sec. Okay, so now I need to now I need to actually uncomment this thing, right? And I wonder what will happen. Okay, that's not working. It seems like I can't printf anything while I'm in that region, which really sucks. Wow. Why would that be the case? I think that means I have a bug somewhere. In a kind of a bad way, I think. Interesting. So I cannot debug print that? Is that what's happening? I wonder if I can just regular print this, like regular, like does the debugger work actually? Okay, so I'm at load I could the first time, and it's pointing to the garbage. So I'll just continue past it. Now I'm at the second time, and it's actually pointing at a real elf. So I kind of wonder what's going to happen. Assert. Does this work? Okay. Okay. 3, okay. It would also probably be good to have a read elf open. Oops. Point. Wow, really? Oh, what? There we go. That's why. Read elf object user breakpoint. because we can use this to verify, we can have this reference open to verify what's actually in the elf. And we can see that it has 3 program headers, which matches what we're seeing in the debugger. So at least I can debug the code in the debugger. Very interesting that I find myself in a situation where I cannot use print statements, but I can use the debugger, weirdly. Very strange. But yes, it says we have 3 program headers. Good. And so I can't print anything. I kind of want to debug that though, why I can't print things. I think I might take a side quest to just do that quickly. So cprintf, so what do I know? I know that panics don't work, and I know that cprintf doesn't work. What does panic do again? Panic calls this function, which calls a cprintf. Panic 1, 2, 3. So I'm going to add the panic back, and I'm going to observe it. Oh. Okay. I'm going to kill this. Okay. Can I kill this? And now it's rebooting because of some reason. And now I'm curious if I... Wow. Wait, just curious. cprintf user panic in while let me just observe that really quick. I kind of don't remember it. Okay. Yeah, like that, like what's happening here? Get env ID. File and line. Hey James, the first FIC uses light mode. Thanks a lot for the light mode comment. You're person number 2 today to comment on the light mode thing. Yeah. No, light mode is better. That's during the day. Light mode is definitely better during the day. That's my opinion. Okay, but so whatever. I was doing this panic thing and it was making my machine reboot or whatever. So now the question is, what happens if I remove all the cprintfs from panic? Oh, interesting that it does it int 3. I actually didn't know that. Which is kind of odd because I don't expect that to be able to handle an int3 in any way. So this is also doing it. Maybe it's the int3. Like what would happen if I added these all back, but just made an infinite loop? Did that fix it? No, it's still rebooting. Did I do that right? It's still rebooting. Okay, wait, what? Okay, wait a second, but if I put this back, surely it still reboots there, really? That is so interesting. What if what if I just infinite loop like all the way at the start? That it still reboots. Now that is something I do not understand. But actually, now that I think about it, I could probably use the debugger to debug these reboots, because I think I've seen that in the past. That sounds worth it to me. Let me do that. Oh, oops. Damn. Okay, one more time. Load does this work? Nope. Continue. So now we're in this panic thing. Let me step inside. And it rebooted, I think. That's just what happened. It just, like... Interesting. Let me do that again. Code, continue. Oh, wait, okay. Wait a second, what? I wanted to break and load iCode. That's what I thought I did. But then I disassemble and it says that we're in check load iCode, which is, what? That's so confusing. I'm so lost. Wow. I thought I'm pretty sure I was in load iCode, but the disassembly says we're in check load iCode, which doesn't make any sense at all. I think something is super wrong. All right, break time. Oh. There's a move CR3 thing. I think there's just something wrong with like the disassembler or something like that. Actually, yeah, you are, Enrico, you are right. Optimizations are on because I couldn't figure out how to, like when I disabled them, it just crashed the kernel. But yeah, I wish I could debug without optimizations, but it crashes the kernel if I disable optimizations. But if, oh, that did it. Wow, this is so confusing. That instruction, oh, the stack, interesting. The push instruction. Yeah, I know. When I had changed -G to something else, it to disable optimizations, it crashes the kernel. The kernel like only runs correctly with optimizations or something like that. And I didn't feel like debugging that also, but it's a good point. So it seems like it crashed on doing a stack operation, which was really weird. Continue. Enable the docents without disabling optimization. Let me see. SG. You might be right. So I'm passing. I'm passing -G. Make, right? You can see -G. You can see -G everywhere. So it's definitely enabled. Wait, man, how do I list breakpoints? Yeah, so that's not info breakpoints, right? Continue. There it is. So it's on the first like stack operation. Although I am very confused. Oops. I'm very confused by the kernel. Yeah, what up, Sid? Oh shit. What's that? Okay. Load iCode. What? Maybe, yeah, maybe it's getting inlined, although that would be quite weird. Check what I got in code. Yes, it's getting inlined. That's why we're directly seeing this move to CR3 within check load icode and not otherwise. Oh man. And oh yeah, Enrico, the top right is my Git client, which is called lazy Git. It's getting inline. What the hell? Okay, let me return this to like some kind of sanity real quick. So this should hopefully make it stop rebooting. And now maybe I can try to disable the optimizations, which I'm pretty sure I did last time, and it broke everything. So I change this to 0. Have you tried to step until the instruction that it crashes? Yeah, I just did that. Just like literally right here, it crashed on the push. So we switched the CR3 and then tried to use the stack, and then it crashed. So that's already suspicious. But now I'm kind of curious about, now I'm just so annoyed that the function's getting inlined that I want to kind of come back to this thing. So just curious, what happens now? Yeah, this is the problem that happened. If I disable optimizations, nothing works. Which is crazy. It like even doesn't, it fails at some really early stage. And that is so weird and very inconvenient. It's like playing on like an extra level of hard mode where yeah, there's probably some problem with the stack pointer for sure. I could probably, well, okay, I could like diff the assembly, but I don't know if that would be helpful. I could probably try to just load it into a debugger. And see what happens. I don't really know what I'm doing. I'm stepping through the bootloader. I have no idea. There's probably a much smarter way to do this. Like I could probably, well, but wait a second, it's so weird that it's even running. Oh, maybe it's in a loop. Could that be what's happening? Is it possible that it's in an infinite loop? It might be the case. That's annoying. Okay, yeah. But this is like starting way too early. It's way too early to debug from this instruction. It's literally like executing the BIOS. How do I set a, like I want to set a breakpoint even in just the bootloader. I actually don't really know how to do that though. Yeah, okay, maybe I'm going a bit too deep. Maybe I will again just decide to ignore this problem and kind of step back for a moment. So there's that known issue of like disabling optimizations breaks everything. So now I will come back to what I was doing and try to, yo, sheesh, thank you, man. I feel like, yeah, I don't know, this debugging stuff is pretty lame, actually. Wish I didn't have to do this. So yeah, let's take another look. And yeah, that's the interesting thing. So is there some way to GCC disable inlining? No inline. Maybe, yeah, maybe some UB. That's definitely possible. Okay. Where does this go? Void. Like this? Okay, now load icode has its own function because I specifically added this no inline thing, which is crazy that I needed to do that. And now I can actually break point on it in a more sane way. Yes, and now I can step through it better. Oops. So now we oh wait, does padder have a branch inside of it? Yeah, it does. Wow. It has basically an assertion inside of it. That's why it emits this branch. Okay. Okay, and here we are at move CR3. So yeah, what is ESP? Wow. So yeah, ESP is like some pointer. Yeah, this is the time where it would be very nifty to have some like debug functionality for me to test like how my page tables look. And that was an exercise that I skipped in the last lab because I wanted to move forward. And now I'm kind of regretting that. It'd be so nice to dump the page tables, yeah. But yeah, it is a stack pointer. And does it look right? I mean, it looks right to me. It starts with an F and is pretty high. Where's our stack again? Our stack. So current base starts at F0. It's like 7 zeros, which matches this. So there's some Yeah, there's just some problem with the stack. Maybe. But to zoom out one level, why? Oh, wait a sec, I see. Okay. The problem is that it's trying to, like, I'm trying to call a function with this panic thing. And the act of calling a function requires touching the stack and writing to the stack. And there's some problem with my stack. There's some problem with being able to access the stack right now. And this is why it works. This is why it's okay for me to be executing all this code here, because it doesn't ever touch this. It doesn't ever call a function, but does it touch the stack? Huh. I would actually kind of think that this stuff touches the stack, which should not be legal. Yeah, like, it crashes on this push instruction. It doesn't even get into the panic because the stack is not even valid to push an argument onto. I mean, I can show you. Let's just, so, RPC, right? The current program counter is AA3. Sub does not jump. Sub just decrements the stack pointer. And so this works. That worked. And then now we're at AA6. And now we're going to try to push something onto the stack, and that's going to fail, which it just failed. It rebooted just now. So the problem is writing to stack memory does not work, which means my like stack is not mapped or something like that. Yeah. Bro, why don't you just use pwn debug? That's a good question. I didn't set it up. That's the answer. Does pwn debug work for kernel debugging? I guess it probably would. I don't know why it wouldn't. I just didn't set it up. It's definitely not a Stack Overflow. I'm pretty confident it's not a Stack Overflow. I'm pretty confident it's my memory mappings are wrong. And so that means it's actually an important problem. But the question was, why doesn't this stuff cause the same issue? I can also reproduce this issue by calling literally any other function. I could make a new function int my temp func, right? I can, anything that takes arguments. Return 42. And I don't know, that would be so. So I could call this temp thing, and the same thing would happen. My temp function, because it's trying to call a function, and that's not working. The load iCode, right? continue. That's right. Okay, I was trying to demonstrate that by calling my temp func. Which I was trying to demonstrate a call, but it still inlined it. Okay. I think it optimized it out. So I think I need to do something like, I need to like use the, if I use the return value and also I don't know if this makes any sense. Make. Did that not change anything? Then what if I like print it? That's also going to this is totally not going to work, but just to force the compiler to like omit the function call, I really want this to work. There we go. Okay, so now this thing is like finally not getting optimized out because I've appropriately done some stuff with it. And now we can just observe that, oh shit. Oh, see, okay. I mistyped the, load iCode, continue. So now we can see that there's this myTempFunc call. And so now let's step all the way down to it. Right, we're almost there. Yeah, we're basically there. So we're at the sub and right, SI, we're gonna run that, it's going to work. Now we're at the push and it's not going to work for the same reason. Okay, I did the disass. Okay, then step I, it crashes. And so that's just to reiterate that it's not a problem with panic. It's a problem with calling any kind of function, which is really bad. And I need to fix that. Man, okay. I was kind of waiting for some kind of critical issue like this to pop up that like ruins my progress, and it's finally here. I thought I was gonna make so much progress today, but I guess not. So now we need to debug why that doesn't work. And how do we do that? So basically I need, like, something is wrong with the mappings. Something is for real wrong with the mappings. And the mappings are in what? Env.c. Env setup VM. I mean, that's where it would happen, right? And I'm pretty sure like this, so here's where we set up the mappings. And the problem was that this, like, No, it's very weird though. Oh, I see. Wait a sec, I see. Let's consult the memory layout. Okay, no, this is, So I have a lot of thoughts going through my mind right now, but like, okay, so, but what was weird is that it was the stack pointer was firmly in like our kernel high memory area, which I think is correct because the kernel stack that we're running on is just a part of the kernel binary. Kind of want to just start fresh. So if we go to entry.s, that's where we set up the stack. And the stack is just, it's just part of the kernel basically. Eventually we were supposed to, we did allocate some memory for a separate kernel stack to transition to, but I don't think we ever switched to it. No, okay, what am I doing? Init.c. It'll be in mem init. Like all of this code, I believe, is still running on the same initial kernel stack. All right, 20 seconds. All right, this sucks. So presumably, yo, Sudara, what's up, man? How are you doing? I am struggling to debug some like really crazy shit right now. Okay. All right, I'm at a little bit of a loss of how to proceed. I think I need to record some of my thoughts and get them out somewhere. All right. All right, the bug. What's the bug? Calling any function after switching to and pagedir. That's switching to environment page. Have you checked the comment if your machine reboots? reboots. Yeah, I think this is what you're talking about. That last successful call. The thing is, it didn't reboot here, which is why I kind of thought I did this correctly, because it didn't reboot. It's rebooting later. Look, calling any function after switching to environment page dir boot loops reason, or maybe theory, or so what do we know? Observations. It resets the machine when pushing arguments onto the stack. It seems like the stack memory is not mapped anymore. Wow, these stickies are very big. Some ideas, one interesting idea would be to diff the page directories for the main kernel one and for the user environment. One thing that's kind of interesting is that, so one thing that just clearly shows that at least the kernel page directory is kind of working is that we can like make all these function calls, I believe. So for example, I can set a breakpoint in mem init or something. I kind of want a breakpoint around here and check page free list, for example. Check page free list, and that like, oh, oops, and I want to finish. Where are we? So yeah, check page free list. Actually, what function are we in? Okay, I'm super confused. I have no idea actually. I just wanted to breakpoints. Oops. List. Oh, so annoying. Okay, what mem init, right? Here we go. Here's where we call check page free list. So I want to break on this instruction. Oops. What the? Oh, that's not D. There. Did I copy this right, first of all? All right. Is that what you need? There we go. And then I want to continue. And now we're there, right? Although why is it, why is it saying check page free list 1? Oh, because I broke at the wrong place. Because there's multiple calls to check page free list, apparently. I think this is the one that I want, right? Okay, so now we're broken at the right place. We've just successfully changed the CR3 to the kernel pager one that we've just tried to populate. And just the question is, do function calls like work? They almost certainly do. What's going on? Why? Why does it take forever to, oh, I missed it. It was like above. It was right here. So yeah, I'm just going to do some step throughs, and we should observe that function calls like 1000% work. I mean, push, move, push. Like we're pushing like crazy. And our stack pointer is this. I'm gonna take a note. Pointer, current pager. So this is, I should have taken a note of what the other stack pointer was, but I'm pretty sure it looked very similar. Just curious. So our state of the code is currently in a state where it would panic, so that's good. So now, so we're just observing that it's totally legit that we're like calling functions and stuff. We've just observed that it's totally legit. So now we can go to the load I code and continue there. And then continue to the next one. Oh. All right, this is interesting. I kind of, we're at the garbage call, and I kind of expected to hit the next load I code, but then it seems to actually reboot. Which is weird. Last step. I really need to, okay, I need to set up my, like GDB hook or something to, yeah, this is like so annoying. 1 second. I'm gonna ask ChatGPT how to, GB, how to set stop hook. Define hook stop. That's what I want, right? Oh, not really. Oh, wait, do I already have one? I do already have one. But I didn't write it. Oh, wow. I just want to be constantly disassembling. Oops. Oh. Okay, whatever. Okay, I messed things up. Okay, I'm just gonna not mess with things anymore. Okay. Okay, so we had just observed that it was totally valid to call functions with the kernel, the current pager activated, I believe. And we recorded the stack pointer, and now I'm trying to go observe the issue again, CR3. And specifically, it's like approximately, well, the weird thing was that, yeah, whatever. Okay, I see. Because we have this panic that just immediately panics, that's why. Okay, so now it's time to, hey Prakash, I don't have time to totally explain it, but I'm debugging why my kernel is so broken right now. And specifically here. And so let's take a note. Broken stack pointer. But I think that's the key takeaway is that it's not a problem with the stack pointer. It's a problem with the virtual memory. And that is the problem. And I think that's a hint to take a look at and instead of VM, right? Actually, I actually have one curiosity. So basically the question is, so what is the code that's responsible for this address working? That's the question. This address simply does not work to use it when we're in the user environment virtual memory, but it does work when we're in the kernel virtual memory. And the question is, so what is the code that's responsible for making that work? And the answer, I believe, is these two lines. So that address, it's like F with like 7 digits after it. That address lives in the high memory in the kernel base region, which we can also see here. It's this kernel base region, and actually I have one kind of also a little curiosity too, is that we have like current page or entry page, right? This is our entry. Our page directory on entry, which maps the current base, but only the first, I think 4 megabytes. But okay, but then in theory, we should also be so what does this function do, first off? It basically maps a region of virtual memory to a region of physical memory. And so the second argument is the virtual address basically to map, and then like a size. And the idea is to map basically all of the rest of the 32-bit address space, which is only because this is pretty high. I think there's only 256 megabytes available. So the idea is to map that whole thing to the first 256 megabytes of physical memory. And we can do that by passing this size from the current base all the way to the top as the size. And then the next argument is the physical address, which is just 0. And it should be writable. And it would actually be really interesting to comment this out. and then observe a similar failure around here. I'm going to do that. I'm going to comment this out, which should really break things. So we'll notice breakage, I think, as soon as here. So I'm going to build, and then I'm going to refresh this, and then check current page dir, right? Okay. I'm trying to find the corresponding place. That's wrong. Is it here? No, it's not there. I think it's, man, why is this so hard? I just want a breakpoint basically right here. Maybe CR0 will be more unique to find. Okay, this is very annoying. Mem init, where is that? Okay, now I can look for check page free list and go to the other one. Oh, I see, that's why. I thought this was, okay. We've been here before and I misinterpreted because I thought this was a function, but this is like the inline function. So let's break right there. Make here d bam. Wait, what? Okay, did I do that wrong? GB. Wait, I thought I did that right. This DB thing, right? Okay, just for safety, I'm going to break at a little bit of a different point up here. There we go. Oh, but assertion failed. Oh, that's why. Okay. Now, because I broke the code, all like these unit tests and stuff fail. So I need to disable that call. That's why. Okay, one more time. Okay, actually, let's do this one. Okay, good. That's set. Now we continue. And we don't even get there, actually. Wow. Oh, maybe, wait a sec, I don't know. Oh, all right, it's already 6. Okay, 15-second break. All right, I do need to get going, but it's so interesting. Okay, let me just get back to kind of a sane place. Panic 22222, or after boot map region. Let me just observe this panic. right? Okay, good. So now, actually, yeah. That's exactly what I like. This panic should trigger the issue. And for example, does this work? I think this should work. Yes. We switch to this thing and we're still able to make a function call as we would expect. And then now, okay, so now if I break the production code but keep the unit test, it should fail in the unit test. It fails in the unit test. Now if I remove the unit test, I remove the unit test. I've broken the mapping, and my theory is that we're going to execute through here. We're going to switch the kernel page directory, and we're going to hit a bunch of reboots when we hit the panic. Let's see if I am right or wrong. It's okay, sick, okay. Whew. So now it's rebooting like a lot, and so it's the same symptom basically. So that's good. So that's good because now it gives me more confidence that this part of the code is what is the source of the bug. Specifically, this boot map region call with the virtual mem and adder thing and whatever. Because if I add this back, the panic works. And it works. There's no scary reboots. So that is good news. So then that basically leads us to the part of the env code here. So here's the function where and just for context, so the code on the left that we were just looking at, that's the code that's setting up the kernel and all the kernel's mappings. The part on the right is the one that's setting up the process mappings, because I don't know, for some reason right now, the kernel has one set of page directories and mappings, and processes have another, basically. And there are certain mappings that should exist in both of them. And so we've just seen that there's this one call that sets up a certain mapping that's vital for doing function calls, basically. And that happens over on the left in this boot map region thing. And on the right, there is a totally identical, or supposed to be identical, set of calls that should, in theory, set up the same thing for the, for the user environment. And that's why I'm pretty confused, because it looks totally the same to me. Because I literally copy and pasted the code, and all I changed was that we're doing this to a different page directory. It's the env page directory. But wait, so, and I made sure to call this, right? This is definitely running. Huh. Crazy. But at least we're making progress. So I'm just gonna, at least a little bit of progress. So I'm just gonna go back to the debugging board. I'm just gonna say confirmed. The same symptom happens if we remove this boot map region call. The current page there. If we remove this boot map region call. So the only question is, what's different here? what is different here? Pretty sure I copied. Can this fail? Like what? Can no, it cannot fail. It's void. But basically what I want right now is some way to dump the yeah, like dump the mappings and stuff like this, which is what they kind of told me to do. I think it was here. They were like, you should probably, no, you should they were like, challenge, you should probably extend the monitor to display all of the mappings in an address range. Do anything else you think will be useful later for debugging the kernel. There's a good chance it will be. I did not do any of that. And now it's coming, and now I'm wishing I did, so maybe it's time to do that. All the mappings that apply to a particular range. I might enter show mappings, blah, 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 blah. Physical page mappings and corresponding permission bits. Yeah. It would be, yeah, because that's kind of where I'm dead ending right now. Because I'm pretty confident that the issue is due to something being wrong with this. This mapping, although maybe maybe I can debug it in another way with the debugger, basically. This might kind of suck. Yeah, it might kind of suck to manually dump the page tables in the debugger, like with raw debugger commands. At least though, it might be kind of nice to just write a utility function. Yeah. let me try this. Load icode. So I want to write a utility function, dump page directory t page directory, and what is it going to do? So you give it a pointer to a page directory, and for int I 1024, all it does is right? No. Oh, wait. Give it a pointer to a page directory, and it just goes through each, and prints out which one is present. There's 1024 of them. Yeah, so I think this should be pretty doable. basically if tp f present, for example. I don't know, this is kind of dumb. But at least it's going to hopefully print. I don't know, maybe that, like, I'm curious if this works. So I'm going to do this. I'm going to add, okay, I'm going to do it higher. I need to do it right here. So I'm going to add debug, panic, and page directory, and page dir. And I am curious what this is going to print out, if anything at all. Oh. What? Oh, okay, clearly I'm messing up. Okay. Okay. That's a bit. Uh-oh. Okay. So a bunch of these things are present. So at least that's true. But yeah, I'm trying to check. But I feel like I've already written a bunch of functions that would be helpful here. I'm trying to check if a specific address is mapped, and I feel like I already have all these functions for doing that. Page lookup, right? Given a page dir, yeah, and given a virtual address that tries to query it, that's exactly what I want. So let me just try that. Maybe that's an easier way. And I believe these numbers should be, so it's the same. So these are very close pointers. So basically, yeah. So what I want to do is right, is that correct? Okay. So struct page info, right. So right. Hey Peter, this is my own kernel, although not really, because I'm just kind of following this coursework. But I'm calling it my own kernel. Yep, I've written a bunch of code here. So that's. So what's gonna happen? So this is actually before. No, yeah. So this is while running with the working kernel page directory thing. Yeah. Let's just see. Oops. Go. Unsigned int. Oh shit. That's interesting. Debug panic. So that succeeded. So it succeeded, which means it was mapped, right? Maybe I want the page table entry. I feel like I'm being kind of right. Okay, so PT, right. Right, okay, so cert PTE and yeah. So there is a page table entry. Just real quick. That definitely should work, right? Debug panic. Just to make sure, this should now fail. Yeah. Here's hey Mazen, here's the class I'm following. Learn. And here are my resources. Yeah. Right, so that's definitely legit. But that's so strange. It's very strange that we can actually query the page tables using this function and give it this like stack pointer thing. And I'm pretty sure that it'll be this, like every time it's the same, like there's no randomization. Yeah. Why am I not? This thing is a little bit strange. Oh, is that all getting inlined? I'm so confused. Why am I feel like I should be seeing a CR3 load, but I'm just not seeing it. Is that because there's something in here that's like annotated as no return or something like that? Oh, whoa. Strange, if I remove this, or maybe I just didn't compile. Oops. Load iCode. Yeah, main tools. Yeah, pretty much make file build system using GCC, GDB, all the normal stuff. And there it is. And for some reason, like now it's all appearing. But when I have the debug panic, it just doesn't, it just stops emitting all this code. Anyway, okay. I am going to assert. So my main goal is checking the stack pointer. I'll just set a breakpoint here. Oops. Please. Okay. Okay. And the goal was to observe the stack pointer right here. And it's this EF3C thing, but okay. Which is slightly different somehow from last time. I kind of want to try again. Okay, EF3C. So I think it's just that, okay, it only changed because I've been changing the code, I think, a little bit, maybe. But in general, it is the same address every time. And it's very interesting that this thing says it should be valid, right? But, oops, but it's just like not, and it reboots. Okay, man, that's scary. I don't know. I mean, yeah, like I haven't finished debugging it, but I do need to get going. And yeah, I mean, I made some progress, but I'm still not really close to figuring out the real reason. So, but I can update my debugging board. So it resets. Hijdir work. I verified that the env setup VM uses the same call. I verified using page lookup that the address definitely appears mapped. Sure, why defaulting? Maybe permissions? Is it possible that permissions is a problem? I don't know. Sorry, where are we? So So yeah. But I'm making it writable. Like it really feels to me like totally. Maybe one thing I could do is, so now I have the page table entry, and I can I can try to like do some stuff with it, like wow, I kind of forgot the macro pdx, etc. But I want to get the it's page adder. What does it look like again? No, looks like this. It's just like the physical address. Yeah. PTE adder, that's what I was looking for. Phys adder T. X. Oops. And it definitely looks like it's mapped. It has a PTE adder. And just out of curiosity, I'm just gonna take this thing. P, and if I manually P, so I want you to convert that to physical address. Just double checking, is that what I want? I just want the one that subtracts, right? Yeah. But I also kind of want to just mask off the low ones. But yeah, it's like, but I can clearly just see it. You can see the physical address within the virtual address because it's just a conversion. So the physical address is this 10E1000 thing, which is totally what we see here too. I'll just run the code. And yeah, so it really does look like it's mapped and everything. Which doesn't really help me. So like, it would really seem as if you should really be able to write to that address. It would really seem like that should work to me right now. But for some reason, that does not seem to work. And I'm not quite sure how to proceed. Yeah, what do I do? Like, what do I even do? We have this pointer that it like totally works when you have the kernel page directory. If you switch to the user page directory, that pointer no longer works. The semi-obvious theory is that the virtual memory mappings are not correct for the user process, and that pointer is not mapped anymore. I checked that. It very much looks like that region is mapped. And yeah, like has all the right, like has all the necessary things. Is it maybe this writable, readable thing? Is it possible? Assert. PTE. I really would be embarrassed if somehow this is the reason. I would also be very relieved. Nope, like it looks writable. Can we just cprintf the whole thing? Wow. PTE. And just like look at it. Oh. So it's a very oh, wait a second. I was gonna say, isn't it a bit short? But no, I think that's fine. It's just, there's just a bunch of zeros we just don't see above it, but that should be fine. Yeah. And all we see extra is a 3, because we have the present bit and we have a read writable, and it's set to writable. I wonder if this user supervisor thing, but no, it can't be that, because we're very much still in supervisor mode, I would hope. Although that is actually kind of interesting. Should that actually be set though? No. So by default, right. By default it's 0, which means supervisor only, and then you opt it into user mode accessible with 1, and we don't want to do that. All right. Yeah, that's hard. I don't. Not sure. Not even totally sure how to proceed exactly. All I know is that this pointer doesn't work for some reason. Yeah, and I've done what I can to try to debug it, like looked at the page tables. And tried to examine them. And I've done so, and they look right to me. Just for a test, I wonder what would happen if I used the kernel page dir here too. That's a cheap experiment, yeah. Kernel page dir. Like, what would happen if I did that? I would expect to see basically all of the same things. Right. Although, wait a sec, no, what's up with this 6? What is up with that 6? What? So it's like 6, 3, right? So the 6 is in the second nibble, so like 4, and that's going to be accessed and dirty, I guess. So I don't think that's relevant. Oh man, all right. I think those are the dirty bit. That's the dirty bit and the access bit. Okay. But in general, it looks quite similar, and it resolves in the same way. Instead of, it's exactly the same, just 10 E063, 10 E003. Hey, Insane Tux, I am using VS Code and iTerm 2. All right, well, that's a tough one. At least it was very encouraging to see that commenting this out produces the same issue. Just to see that one more time. And it reboots and reboots and reboots. So that is pretty... Oh, interesting. Can I call this helper function? But can I call that helper function, that checker function, but just pass it a different yeah, a different page directory would be sick. And probably not too hard. Would it pass though? Check the pages array. Pages, envs, physical memory, and the kernel stack. I think so. I'm gonna try to do that, I think. All right. which will be kind of annoying because it's not public. And it's only ever called in pmap.c right now. So as a last thing for today, I'm going to export this as public and make it take a, ooh, I could change the oh, then I would need to change all these callers, which is annoying. So maybe I will actually make another one. I'll make a second function. Okay, I know. I'll keep the existing one. And I'll have two functions. Custom. Let's see, page dir. And so this one will be named core current page dir. And then this one will use the given page dir. And then this thing will use this and input page dir. And I'll just do this. So now we're able to pass in a page directory. So I haven't broken any of the callers, existing callers, but now I have my new fancy function, which I can export in the header, check current page dir custom, and I can even like call this places. Yo, digitalized, yeah, I need to leave. I mean, I'm just so stuck on this bug. Like it's really kind of pissing me off. Check current page dir custom and page dir. And page dir. Panic. Yeah, I really, because I have all the context of the bug stuck in my head right now, and I'm going to like lose it. Oh. Implicit. Oh, sheesh. All right, now I need to go and declare this. It's super annoying. Assertion failed. And just to be clear, it's actually, if I remove this thing, we just get the panic at the 111 place, right? Yes, and so it actually seems like I have some bug where something should be writable and it isn't, which is actually really nice to see. And just for a sanity check, I should also be able to pass in the current page dir into this function. And this should totally succeed. Oh. Wait. Okay, that failed at a different place. Okay, I don't know. Super strange, and we'll need to pick it up next time because I do need to leave now. but I'll just leave a comment. So trying to debug why npager was crashing with stack accesses. Had the idea to use the existing thing checker function to validate it. It failed with some writable assertion, which is interesting. But somehow the kern pager, which should be passing, is also failing. Okay, and I'm gonna leave it there. Thanks a lot for joining the stream. Feel free to join the Discord if you want to stay in touch. Subscribe, comment, and like if you enjoy what I'm up to. And I'll see you another time. Peace.